So we can find the mass percent composition by doing an experiment, or we can calculate it from the chemical formula. So the mass percent of element X is still the mass of element X divided by the mass of the whole compound. But now, because we're looking at a compound and we're not looking at a specific sample, we need to just choose an amount to look at. And so what's convenient is to choose 1 mole. So we're going to say, well, how much of element X is in 1 mole of the compound, and how much does 1 mole of the compound weigh? We plug it into the formula, and we get the answer. So acetic acid is the active ingredient in vinegar, so it gives it that distinctive smell. Calculate the mass percent composition of oxygen in acetic acid. So we want percent oxygen. We want grams of oxygen divided by grams of acetic acid times 100. So we're going to choose 1 mole as our size, because it makes everything easy. Let's calculate the mass of 1 mole of acetic acid. So for acetic acid, 1 mole, we've got, you can combine the hydrogens if you want to, or leave them separate if you want to. So there's 1 hydrogen out front, and then there's 2 carbons, and then there's 3 more hydrogens. And then there's 2 oxygens. So 1.008 plus 2 times 12.01 plus 3 times 1.008 again, plus 2 times 16 equals 60.052 grams. That's the mass of 1 mole. So that's the mass of 1 mole of acetic acid. What's the mass of oxygen in that? It's hiding in our work down here. 2 times 16. This is the mass from oxygen. That's the grams of oxygen in 1 mole of the whole compound. So there's 32 grams of oxygen in 60.52 grams, and multiply by 100%. So 32 divided by 60.052 times 100. Now what should we do about sig figs? Well, I was using significant figures, molar masses that had 4 sig figs. And so this one I've told you, just use the whole thing, don't worry about it. This one, though, is easier to think about. 2 times 16, that's going to have 4 significant figures, right? This one's going to have at least 4. We're not going to worry about it. And so we're going to say that this answer has 4. Is that a 2? That's a really weird looking 2. 29%. Oxygen. Any questions? Yes? Okay, so I've taught you significant figures, and there were problems on the first exam, specifically testing you on significant figures. There will be a couple of problems like that on the final exam. I want you to try to use significant figures, just practice. But I will not intentionally trick you with sig figs. So we're going to try, but I would rather you focus on remembering how to do this. Don't stress out about the sig figs. So that being said, what I did here is this 32.00 came from multiplying 2 by 16. There are exactly 2 atoms of oxygen times 16. This had 4 sig figs. So this number has 4 significant figures. This one, coming from adding those up, also would have 4 significant figures. And so that's why I rounded this to 4. Any other questions?